Hello everyone, today we're going to look at Unit 3, Lesson 5, Factoring Complex Trinomials. So we'll start by looking at a simple trinomial that we had seen in the previous, like the ones we have seen in the previous day's lessons. So how does x squared plus 4x plus 3 factor using the area model? So we'll set it up in the area model and we'll also use SPF so that we are comfortable with both strategies and talk about how we're going to use that strategy today to factor more complex trinomials. Okay, so we have our expanded form. We know in expanded form we want to put our leading term in this box, so x squared is my leading term, and then that plus 3 is my trailing term, right? Leading term just meaning the first term, and trailing term just meaning the last term. Then we have to think about how are we going to split up this middle term, right? We know something about what these two squares are going to have to do. Okay, so if we think back, we're going to use SPF, and we know that we need two numbers that are going to add or sum to a positive 4, that's my middle term, and they're going to have a product of my last term, which is a positive 3. So think about what those numbers would be. We could list the factors of 4, but there are only a few. So I think we can figure out that we're going to have a positive 3 and a positive 1. And if we just wanted to check it, we could say, okay, 3 plus 1 is 4, and 3 times 1 is 3. So that kind of checks for my SPF. So we'll have a plus 3x, and we'll have plus 1x. And then we pull out those common factors. So if we look at our column, our first column, we have x squared and 1x. So my greatest common factor is just x. My second column, I have 3x and I have 3. So plus 3 is my GCF. And then if we take a look at our rows, we have x squared plus 3x. So my greatest common factor on that top row is just x, and just a plus 1 on the bottom. And once again, we know that those represent our factors. We can write in factored form, x plus 1, x plus 3. So far with our factoring, it's been pretty straightforward with once we find two numbers that add to our middle term and multiply to our last term, we can just take those two numbers, the positive 3 and the positive 1, right? And we can just write them right in the brackets. This is because this is a very specific kind of trinomial that we call a simple trinomial. Okay, so this is a simple trinomial. But today what we're going to do is we're going to look at more complex trinomials. And what makes this one that we first started looking at a simple trinomial is that it has a coefficient of 1 on that x squared. Right, so we don't really have to deal with anything that's going on with the x squared. Everything we work with is just with that second and third term. But as soon as we introduce a coefficient or a number on our x squared, the way we go about factoring that trinomial is a little bit different. So let's take a look at a more complex trinomial, and we'll look at, again, how do we make that work in terms of our area model in a rectangle. So how does 3x squared plus 10x plus 8 factor using the area model? So I start here with those algebra tiles we looked at in the previous day's lesson, and I have 3x squared, so 1, 2, 3. And then if you count how many x tiles I have 4 across the top, and I have 6 across the bottom. So that represents my 10x squares. And then finally I have 8 ones, right? And they've already been arranged here so that they're in a rectangle. We can see that this is how you'd have to lay them out, essentially, so that they would fit within a rectangle so we can make that area model. So if we wanted to represent that, we could say, okay, across the top, we have 3 x, and then on the side here we have plus 4, right? We're looking at the width of each tile piece. And if we look down the side, so if we look down the side, this width represents x, and then this is a width of 1, 2, so we have a plus 2. Okay, so that tells me that when we factor this, we should get 3x plus 4 and x plus 2. So we should get 3x plus 4 and x plus 2. Let's check this using our area model as if we didn't have algebra tiles. So the way the algebra tiles have it laid out, we're going to fill in our square using that same model. And then we're going to figure out kind of, well, what was the pattern there? How do we know that we can also do that if we were just given a trinomial? So in my leading term, I have, once again, I have 1, 2, 3x squared. So I'm going to put that in my leading term, like the inside of my box. Okay, and then in my next square, I'm going to put how many x's I had here on top. I had 1, 2, 3, 4 x's. I'm going to write these in blue. The green doesn't show up so well. And then on the bottom, I have 1, 2, 3, 4, 5, 6 x's. So I'm going to put that in my next box down here. And then finally, my trailing term will be those 8 ones we have. So positive 8. Okay, so if we already knew how to factor this, that looks like that's how we would go about kind of breaking down if we were to expand out our factors. And we know along the outsides, if we're looking at the dimensions, we had a 3x up here, and we had a plus 4. And then we had x on the side, and we had plus 2. And if we wanted to check that by just talking about our common factors again, we could say, okay, in this column, my greatest common factor is in fact 3x, right? So that works, right? 3x here. If we look at my next column, we have 4x plus 8. So our greatest common factor there, yep, that's plus 4, so that works. And then if we start looking at our rows, so our first row, we have 3x squared plus 4x. Okay, the greatest common factor between those two would just be x. And then finally, we'll take a look at our bottom row. And we have plus 6x plus 8. So the greatest common factor there is 2. And we know that those represent our factors. So that's what it's going to be like in factored form. But let's start talking about, well, how could we do that if we weren't giving all of these kind of models in the answer already? So let's take a look at another example. So let's say we were given 3x plus 2 and 2x plus 1. If we put this on our area model, we would put our 3x plus 2, right? Those represent our dimensions on the outside of the box. And we have 2x plus 1. And then we would multiply, right? Because we're expanding and simplifying. So we could either FOIL it, we can expand and simplify by FOIL or using our area model. So I'm going to take the area of this first box I've highlighted in green. So 3x times 2x is 6x squared. And then this box would be a 2x by a positive 2. So that is going to multiply to a positive 4x. And then we'll move down to the bottom row. We have a 3x times 1 is going to be a positive 3x. And then finally on our trailing term, we have a positive 1 times a positive 2. So we'll take all of those and we will add them together. So we'd have 6x squared plus 4x plus 3x plus 2. Okay, we're going to combine our like terms. So we're going to get 6x squared plus 7x plus 2. So that's how we would get it to expanded form. So this is expanded form. But we are going to try to factor this, and we're going to try to factor it by this process called decomposition. Okay, and when we're talking about decomposition, we're basically saying how do we break apart the middle term. We've had lots of discussions about that in the previous note too, looking at how do I know how that middle part kind of breaks apart to eventually add back together when we go to expand and simplify. So we already know the answer to this because we saw it up here, right? We kind of are working backwards. We know that 7x used to be 4x plus 3x. So we're going to decompose 7x back to that 4x plus 3x. So we're going to say 6x squared, and then we're going to break apart this 7x. So it's going to become plus 4x plus 3x. And hopefully we can all agree that 4x plus 3x is still 7x. So I'm not really changing the equation. I'm just writing it with more numbers there, but it still equals the same thing. So if we look at this middle term, remember before that those two numbers that we were using when it was a simple trinomial, they connected somehow. So we talked about before, if we took those two numbers and we added them together, and if we multiplied them together, right, that represented some number in our expression. Well, we can see that the 4 plus 3 equals 7, right? That's fine because we can see that in our expanded term, right? That's our middle term. But the question is, how does 12 relate to our expanded form? So if you look back, we highlighted our expanded form is right here, right? So here's, highlight that yellow. Our expanded form is here. So how does 12 relate to our expanded form? Could you see any part of the numbers there that we could somehow relate to 12? Okay, we know that 4 and 3 add to 7. So they've kind of already, that's how they relate to that number. But what about the other two numbers? Okay, the other two numbers we have are 6 and 2. So is there some way we can relate that to 12? Yeah, there is. Okay, we know that 6 times 2 equals 12. Okay, so if we think about that in terms of SPF, we'll say, so when we're trying to set up SPF, we know those two numbers that we're coming up with, they have to add to 7, but they're going to have to multiply to the product of whatever my first term and my last term are. So it's going to have a product of whatever that 6 times 2 is, which is 12. Okay, and then we still write our F for factors. And we know that those are going to be a plus 4 and a plus 3. Okay, so when we're doing complex, it's a little bit more complicated with how do we determine it's the product of what number. All right, now that we have it in these 4 terms, we're going to factor by grouping. So we're going to group the first 2 terms together and see what we can factor out. So if we look at this term together, we're going to take a look at, okay, what's my greatest common factor for those 2 terms? Right? We can see that the GCF, 6x squared and 4x, that's going to be 2x. Okay, the GCF here, if I group these 2 terms together, is just 1. There really isn't a GCF, but we have to pull out something as a placeholder. So if I was going to write this out so that I could pull out that GCF, I'm going to say we're going to do 6x squared plus 4x. And I want to divide both of those by the GCF for that group. And then I'm going to divide my second group by the GCF I found for that group. So for 3x plus 2, we said the GCF was just 1. Okay, so we're going to make a note here that we're going to common factor from each group. Okay, so I'm pulling out a 2x. I'll write that 2x out front. And then whatever's left over when we divide out that 2x, we'll put in a bracket. So 6x squared divided by 2x is 3x. And 4x divided by 2x is just 2. Okay, then I'm going to pull out that plus 1 that we did for our second group. And 3x divided by 1 is 3x. And 2 divided by 1 is still just 2. So now if you take a look at what we have a common bracket, right? If we look at this as one term and we look at this as one term, we can hopefully see that we have a bracket that's the same in both terms. We have that 3x plus 2. So that's the next step. We're going to common factor out, or we're going to factor out, rather, the common bracket. And then we'll put the remainder from division goes into a second bracket. Running out of room. So what I mean by that is I'm going to divide this first term by 3x plus 2 and pull it out front. So when I divide that first group by 3x plus 2, I'm going to start my second bracket. All I have left is 2x for that first group. When I divide my second group by 3x plus 2, all I have left is plus 1. So you see that that will end up looking like the factors we got in our area model, like the factors we started with at the beginning. Okay, so lots of kind of strategies in order to get those factors. Let's take a look at a couple. We'll use our area model for a few of them, and then we'll get away and just use SPF for decomposition. So our expanded form, we're going to need we're going to put our leading term in this box. We're going to put our trailing term here. And then we're going to set up our SPF to figure out what two numbers do we need. So I need two numbers that are going to add to my middle term, which is a plus 1. And now this is a complex trinomial. So we're going to need two numbers that multiply to whatever my first and my last term multiply to. So 2 times negative 3 equals a negative 6. Okay, so I need two numbers that are going to multiply to a negative 6 and add to a positive 1. Okay, so my factors of 6 are 3 and 2. I have to think about how will those add to a positive 1. If I make this positive and that negative, that will be positive 1. And if I multiply those two, 3 times negative 2 is negative 6. Good. So I'm in good shape. So I'm going to use those factors to go in my other boxes. So we'll have a positive 3a, and we'll have a negative 2a. And then once again, we're going to pull out all common factors. So pull out common factors. So from my first column there, 2a squared and 3a, I just have a as a common factor. From my second column there, I have a negative 2a and a negative 3. So we're going to pull out a negative 1 is my common factor. And then if we look at our rows, okay, 2a squared minus 2a, they have a 2a in common. And then positive 3a minus 3 is a positive 3. So once again, those represent my factors. I can write them in brackets in a factored form. A minus 1, 2a plus 3. Let's set up the second one and then I'll pause the video and see if you can finish it up. So we're going to put our leading term in this box. We're going to put our trailing term in this box. And then we're going to set up our SPF. Okay, we're going to need two numbers that add to my middle number, or sum to my middle number, which is positive 2, and then two numbers that multiply to my first times my third. So that's positive 16 times negative 3 equals negative 48. Okay, so see if you can figure out what those factors are. Complete your area model and write what the result is in factored form, and then we'll come back together. Okay, there's the factors you should have gotten when you use the area model. Pause the video if you need a few more minutes to take a look at that. But now we're going to chat about how can we factor these complex trinomials without using the box if we wanted a little bit of a shorter way. Okay, so these are the steps to factor by decomposition. The standard form of this equation that we're looking at right now is ax squared plus bx plus c. So we're still going to use SPF, but we're going to determine two factors that produce a sum, so my sum is my S in SPF, of b, so right, my middle term, and a product, right, when we multiply my first and my last term, which we're representing as A and C. Okay, use these two factors to decompose. That's the key word here with decomposition. Decompose the middle term. Once we do that, we're going to common factor the first two terms and the last two terms. And then after we do that, we're going to common factor the common bracket. So those are kind of 4 steps. We'll go through each of them of the examples, and then I'll get you to try the last one on your own. Okay, so we have 4x squared plus 13x plus 3. So if we set up SPF, we're going to need two numbers that add to plus 13, and they're going to have a product of my first times my third. So 4 times 3 equals 12, and they're both positive, so they're going to have a positive 12. So if you want to, you can again list your factors of 12, or some of you might be strong enough with your factors, you can kind of just think of them on the spot. So 1, 12, 2, 6, 3, 4. Well, the only two that are going to add to 13 are going to be 1 and 12. So now we're going to rewrite this by decomposing, by splitting apart my middle term. So we leave that 4x squared as my leading term. We'll have plus 12x plus 1x plus 3. Okay, so we found our factors. That was step 1. We use those factors to decompose or break apart our middle term. Step 3 is we're going to common factor the first two terms and the last two terms. I'm going to look at my first two terms and think about what can I common factor out there. So 4x squared plus 12x, I can common factor out a 4x. My last two terms, I have 1x plus 3. The only thing I can pull out of there is another 1, so we'll pull out a 1. So let's see what that's going to look like once we pull that stuff out. So we pull out a 4x, and in my first group, 4x squared divided by 4x is just x, plus 12x divided by 4x is 3. My second group, I'm pulling out a plus 1, and again I'm left with x plus 3. That's step 3. My last step is we're going to common factor out the common bracket. So my common bracket here is x plus 3, and then when I pull an x plus 3 out of my first group, right, that's my first group, all I'm left with is 4x. When I pull an x plus 3 out of this group, all I'm left with is plus 1. Okay, so those are essentially the steps. We set up our SPF, we do our decomposition, we do our common factor from our two groups, and then finally we factor out the common bracket. Okay, let's try another one together and then you guys can try. All right, so we have 12x squared plus 17x, or sorry, minus 17x plus 6. So we're going to need two numbers that add to my middle term and multiply to whatever my first and last term multiply to. So 12 times 6 equals a positive 72. Okay, so I'm going to list my factors of 72 because this one might not be as easy to kind of see straightforward. So I have 1 and 72, 2 and 36, 3 and 24, 4 and 18, we have 6 and 12, and finally we have 8 and 9. Okay, well I can quickly look at 8 and 9 and see that that's probably going to be my winner. We just have to figure out the signs on them. So if they have to multiply to a positive, they're both going to have to be negative or they're both going to have to be positive. And since they're adding to a negative 17, they must both be a negative. So those are the factors I'm going to use. That's step 1. Okay, step 2 is we're going to decompose that middle term. So we're going to split that middle term into those factors we just found. So 12x squared minus 8x minus 9x plus 6. Okay, that's step 3 is we're going to common factor from the first two terms and common factor from the second two terms. So 12x squared minus 8x, greatest common factor there is 4x. My second group, negative 9x plus 6. Whenever you're common factor out of these, we're always going to take the sign of whatever the first term in our group is. So does everyone see this is a negative 9x? So we're going to pull out a negative whatever our common factor is because we always want to not have a negative on our first term in a group. So my common factor here is 3, so we're going to make it a negative 3. So when I pull out, let's label that, that's our common factor from our first and last two terms. and I pull out a 4x, 12x squared divided by 4x is 3x, and negative 8x divided by 4x is negative 2. My second group, I'm pulling out a negative 3, and we have a negative 9x divided by negative 3, we're going to have 3x. And then again, watch your signs here, because now we have 6x, or sorry, 6 divided by negative 3, it's going to be a negative 2. Okay, and then our last step is we are going to pull out that common bracket. So 3x minus 2 is my common bracket. And then if we look, I pull 3x minus 2 out of that first set, I'm left with 4x. And when we pull it out of my second group there, we are left with minus 3. Okay, take a minute and see if you can follow that process and try that last example on your own, and then come back to check your answer. There's the solution for that last one. Feel free to take a minute to have a look or pause the video and make sure you can follow the steps. I'll just label those steps one more time too. So step 1 is to determine those factors, which we did here. Step 2 is we're decomposing that middle term using those factors we found, negative 4 and negative 12. Step 3 is we're going to common factor the first two terms and common factor the last two terms. And then finally, we factor out the common bracket. Okay, so that is all for your note for today.